Hi, this is Ray from PI Exchange. In this video, I'll show you how to create a clustering pipeline using the AI and analytics engine. First, let's quickly go through what clustering refers to. Clustering is a machine learning technique. It's used to identify groups of similar items within a population. It can be adopted in many applications, such as customer segmentation and anomaly detection. Here's an example. Suppose you work in a telecommunication company. You are responsible for customer retention. One of your tasks is to find different groups of similar customers in order to handle each group with a tailored strategy. In this case, groups are defined based on the customer service experience. You'll use a dataset that contains a history of customer service calls over a period of time. Each record represents a service request made by a particular customer. The dataset includes the customer ID, the time when the call is made, the type of the service request, like general inquiry or technical support, the outcome of a call, whether the problem is solved or gets worse, also the waiting time and duration. Now with this dataset, create a new app under your project. Select Clustering under Build from Scratch and rename the app. Customer segmentation based on service request data. You can see 3 steps involved: prepare data, select features, and configure clustering algorithm. The first step is to prepare data. To get started, add a dataset of customer service requests. To see whether the dataset can be used as clustering input, you can check the preview of the dataset. It's obvious that a customer can make service calls for different reasons. For example, the customer with ID 568 made several calls: a general inquiry, a sales inquiry, and another general inquiry. But the goal is to group similar customers instead of service request records. So you need to create a dataset in which each customer should be represented by a single row, which summarizes the customer's experience over a certain period. Now go back to the app building page and select Prepare Data. Then create a data wrangling recipe. Which generates the required dataset step by step. I'll skip the details here. This is the completed recipe. Now on the app building page, both recipe and the processed dataset appear in the flow. Select the prepared dataset as clustering input and proceed to the next step. Step 2 is to select features you would consider in clustering. You need to double-check the type of each selected feature, as this can greatly impact the clustering results. Here the engine automatically selects the type inferred by a large language model, noted as recommended. You can also make modifications. A useful tip is to view the summary of the feature if you are unsure. Once all features are confirmed, continue with step 3. Step 2 is to select features you would consider in clustering. You need to double-check the type of each selected feature, as this can greatly impact the clustering results. Here the engine automatically selects the type inferred by a large language model noted as recommended. You can also make modifications. A useful tip is to view the summary of the feature if you are unsure. Once all features are confirmed, continue with step 3. The last step is to configure clustering algorithms. Here I'll pick HDB scan on the UMAP dimensionality reduced dataset and k-means, following the default configuration in the engine. Then start building the clustering pipeline. The engine shows a summary page while the app is being processed. Once the app finishes processing, you can check the result of a selected algorithm in details. Taking an example of HDB scan, you see 3 distinct clusters identified. The size of cluster 1 is about 67%, which is the largest. The other 2 clusters are of similar sizes, both less than 20%. Below you see a detailed description for each cluster, which provides an explanation of how a cluster can be identified by one or more filtering conditions. For example, cluster 2 includes the customers who are very satisfied with the service, as no request was made in the recent period. For cluster 1, it looks the opposite, as the outcome of their service calls was not good. Then cluster 3 sits in the middle. The customer's issues were resolved and were not many, with only less than 7 calls. Once OK with the clustering result, you can export it to a project or database. Here I'll export result A to the current project. Then, in the results dataset, you can see 3 additional columns appended to the clustering input. Here, cluster ID indicates which cluster each customer belongs to, as described in the result section. Cluster 2 means very satisfied, cluster 3 satisfied, and cluster 1 is less satisfied. This potentially provides a guidance on further retention tactics. To conclude, you've seen how to build a clustering pipeline in the engine to handle customer segmentation. At any stage of the process, no coding is required. If you have any question, please feel free to reach out to our team. Thank you. If you are interested in trying it out yourself, we provide a 2-week free trial.